Hello everyone. Today we'll be talking about the differentiation of this function y is equals to x to the power x. So a function like this is not the normal kind of function that we very frequently come across in physics or mathematics. So let's see how we find the derivative of this function. So let's write it over here. And yeah, one more thing. Whenever there is a variable in the power, it's the best to apply logarithm on both the sides. It makes solving a question like this way more easier. So that is exactly what we will be doing right now. Applying log to the base e on both the sides. And yeah, log to the base e can also be written as ln. So, or ln y is equals to ln x to the power x. And I'm sure many of you know that whenever there is power inside the logarithm function, this power can be written outside. So something like this. And to those of you who don't know how this came, I'm going to prove it for you so that things get simpler. So for that, let ln a is equal q, and we are going to express this in exponential form. So it's going to look something like this, e to the power q, and then we are going to just add the same power on both the sides. This is power q and m, so if we cancel both the same power both the sides, we are going to get the first step, so it's not a problem. And also that added power should belong to real number. And now we are going to express this in logarithm form again. So it is going to look like this. And finally, we are going to replace the value of q, this initial value that we had supposed. So it is going to be ln a times m times m. So we can see that this power comes forward and multiplies this. So this can be written as this. So I hope you understood this. I'm just going to erase it. This as well. Yes. So this is equal to this. And now we're just going to differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So now this is what we get with respect to x here, and this whole with respect to x again. And here we are going to apply the chain rule. So first we differentiate this with respect to y, and then y with respect to x. And over here we're going to apply the product rule. So the rule is like this. First this addition sign, this outside, and with respect to x again. So we applied the chain rule over here and the product rule over here. Now we can write this for ln y with respect to y, dy upon dx as it is, x as it is, and ln x with respect to x becomes 1 upon x, addition sign, ln x, and the differentiation of x with respect to x is 1, of course, so we don't need to write anything. So now we're going to multiply both the sides by y so that we can eliminate y from the left hand side. So 1 upon y times y times dy upon dx is equals to y here. This and this cancel each other out. 1 plus ln x. And this cancels this one. Or dy upon dx is equal to, we're just going to replace the value of y, the initial value, which was x to the power x. So x to the power x, 1 plus ln x. So now let's multiply this with this, and again this with this. So or dy upon dx is equal to this plus this. And finally, using the property of log that we had discussed earlier, we can write this as this. So this moves into the power. So this is the final answer to this question. I hope you learned how to do this, and in the next video I'll be talking about the differentiation of this function, x to the power x to the power x. So this will be the topic that I'll be covering next time. I hope you enjoyed this video. Thank you.